Hello everyone, now we are going to start our next chapter, that is sorting. So the meaning of sorting is arranging things in order. So when we use a dictionary, in the dictionary the words are arranged in the alphabetical order, right? So when we are walking on the road, you may see there are two kind of dustbins. One is blue one and another one is green one. So green one is for biodegradable material and blue one is for non-biodegradable material wastage. So we have seen two kind of different dustbin. Similarly, when we are in school, our teacher used to stand us in a height wise, right? Height wise in order to place us and our roll number are registered in terms of height wise, right? So similarly, when we are shopping, when we are in Amazon using these sort of apps like Amazon, Flipkart, when we are searching for a particular product, we sort products from 4-star rating or 5-star rating, or the price from high to low or low to high, and these all sort of things is known as sorting. So in this chapter we are going to sort a given array. So array is given by our user. Let us consider 5 3 0 1 2, and we have to sort it in either a decreasing manner or in increasing manner. So the order of increasing manner is 0 1 2 3 5. This is a sorted array in increasing manner, whereas in decreasing manner the sorted array is 5 3 2 1 0. This is in increasing order and this is in decreasing order. So these are the two sorting types, either in decreasing or in increasing. So in this chapter we are going to learn about some of the basics algorithm of sorting, like bubble sort, selection sort, insertion sort, and kind of advanced sorting, that is counting sort. And there are also other sorting techniques which is based on backtracking or recursion. So we will study other sorting techniques in detail when we are studying those chapters recursion and backtracking chapters. In those chapters we will study some of the advanced sorting techniques. Now in this chapter we are going to learn about 4 sorting techniques and inbuilt. There's also an inbuilt, but we will study about it later. So these are the 5 things we are going to learn in our class. First of all, let us start with bubble sort. So to understand bubble sort, let us consider array. This is our unsorted array, right? 5 4 1 3 2. This is our unsorted array. So what is the meaning of sorting? Either the array is sorting in increasing order or in decreasing order. You can see that we can sort our array either in increasing manner or in decreasing manner. Bubble sort might sound a little bit funny to you. You might think what we are talking about bubbles and all those things. So the inspiration for bubble sort is when we boil water, when the water gets to boil, some of the bubbles form on top of the water, right, on top of water surface, and that bubble get out of the container or the beaker, whatever the boiler we have. So these same technique we follow here. So let us consider that this is the array. In this array, whatever the biggest element, we push that particular element to the last. So suppose let us consider that this is the biggest element and we will push it towards the last. After that, second biggest, after that third biggest, after that fourth biggest, after that fifth biggest, after that last element. So this is how we are going to sort, and this is the main fundamental of bubble sort. So the idea here is largest element comes to the end of the array. So we will compare two elements. We will start from our first index and we will compare with the next index. If the first index, if the 0th index element is higher, then we will push it towards the left, towards the end of our array. So this is the logic. So we will use swapping between two adjacent elements. So we will compare two elements. If our first element is greater than the second element, then two elements will get swapped. After second element with the third element. So if the second element is greater than the third element, again swap. After third element, fourth element. Again, if third element is greater than my fourth element, then again swapping will take place. So if both elements are same or the first element is less than the second element, then no swapping will take place. So this is the fundamental. Remember guys that the fundamental of bubble sort is whatever the biggest element is there, we push it towards the left. So to understand, let us do a example that this is my array, right? These are the indexes 0 1 2 3 4. These are my indexes and this is my array. So let me write my array here, 5 4 1 3 2. So I am going to start my turn with 0th turn. In the 0th turn, I am going to compare my first index with the first element with the second element. So you can see that my first element, if my first element is greater than my second element, then I am going to swap. right? So here I am going to compare. If my first element is greater than second element, you can see that my first element is greater than second element. Then I am what I'm doing. I am doing 5, 1, 3, 2. So I am going to swap the values of 4 and 5. After that, here 5 and 1 will get compared. Again, if my initial value is greater than my final value, swapping will take place. So again, swapping will take place. After that, 1, 5, 3, 2. After that, again 5, 3, swapping here. Now what I'm doing 4, 1, 3, 5, 2. After that, finally 4 and 5. So 5 and 2, here you can see that 5 is greater than 2. Again final swapping 1, 3, 2, 5. You can see that my largest element here is at the first index. I am swapping at each indexes and checking if my first element is greater than the second element, then swapping will take place. So you can see that this is my biggest element, right? And our logic tells that whatever the biggest element we have, push it towards the last. So this is the initial array and we have successfully pushed our element here. This is my, you can see that my fifth element is at the last. So I have pushed the element towards the left. After that, my turn will get complete. So this is my 0th turn. After that, my first turn. In my first turn, I am not gonna check this element because this is sorted and I only have to focus on this part. So this is my array, right? 4, 1, 3, 2, and this is the sorted part. So I am not gonna check for 5. Again, beginning with the first index. Whether my first element is greater than the second element. Yeah, if greater than, swap. So 1, 4, 3, 2, 5. After that, 4 and 3. Whether 4 is greater than 3, yes. If yes, then swap. After that, 1, 3, 4, 2, 5. And finally 4 with 2. Again 1, 3, 2, 4, 5. So now I'm not gonna check 4 with 5 because I already know that my largest element is at the end. So I'm not gonna check for this iteration, for this first turn. So I'm not gonna check 4 with 5. So these are my two sorted elements. Now I have to only check for these three elements. So my first turn is completed. Now the turn for second turn. In the second turn, this is my array, right? So 1, 3, 2, 4, 5. Right? Now I am going to check 1 with 2, 1 with 3. So you can see that 1 is not less than 3. If 1 is the first element is not greater than the second element, then no swapping will take place. So I am going to check now 3 with 2. 3 with 2. After that, 4, 5. Right? I am going to check what 3 is 2. So you can see that 3 is greater than 2. So swapping will take place. So 1, 2, 3, 4, 5. So you can see that my three elements are sorted now. I have to focus on this 2. So in the third turn, this is my third turn. This is my unsorted part 1, 2, 3, 4, 5. I don't need to check whether for this I only have to check first element and the second element because I already sorted 3, 4, 5, right? So I only have to check whether my first element is greater than the second element. So you can see that my first element is not greater than the second element. So no swapping will take place, and finally our array is 1, 2, 3, 4, 5. This is my sorted part now. So 2 is sorted. After that, we don't need to check for the first element because if all the elements are sorted, then the first element itself is sorted. So this is how we are going to do our bubble sort. So the pseudocode for this is you can see that I am running a for loop. I am running a for loop for int turn is equals to 0. Right? After that, turn should be less than n minus 2 times. Here total elements 1, 2, 3, 4, 5. 5 elements, right? So n is equals to 5. How many times I'm running? I'm running my loop for 1, 2, 3, 4 times. So n minus 1. Sorry, n minus 1. 10 should be less than or equals to n minus 1. After that, I'm doing turn plus plus. So this is my outer loop, and in the inner loop I am running for int j is equals to 0 and j should be less than or equals to n minus 2. Here j should be less than or equals to n minus 2 because you can see that I am not comparing the last element because I am not comparing 5 with 4 because I already know that the last element present here is the largest element for my bubble sort. So I don't need to check it again and again. So because of that, I am running my loop for n minus 2 times. Right? After that, j plus plus. In that, what I am doing, I am swapping basically. So this is the pseudo code for my bubble sort. I hope you have understood the concept and the logic for bubble sort. Now let us write the code in my VS Code such that you will understand it even more better. Now let us create my function for bubble sort. Public static void bubble sort. In this I am passing my array as my parameter. Int arr is my array. After that, first of all, first thing is to calculate the size of my array. So int n is equals to arr dot length. After that, I am running my loop for int turn is equals to 0 and turn should be less than or equals to n minus 1. After that, turn plus plus. In the inner loop, I am running my inner loop for int j is equals to 0 and j should be less than or equals to n minus 2 minus 10, because first of all you can see that in the 0 to 10 we are pushing the fifth element, which is at the first index, towards the last of my array. You can, after that, in the first term you can see that we are not checking for the last element, because we already know that the last element which is there is the largest element. So we don't need to check the last element with my second last element, because we already know that the second last is less than my last element, that is the largest element. So I am running my inner loop, that is j should be less than or equals to n minus 2 minus 10. After that, j plus plus. Here I am going to check if my first index or the first element is greater than my second element. If yes, then swap. If not, then don't need to do anything. So I am checking if arr of j is greater than arr of j plus 1. If this condition is true, then swapping will take place. So int temp, we already know how to swap any two given variables, right? So int temp is equals to arr of j. After that, arr of j is equals to arr of j plus 1. After that, arr of j plus 1 is equals to, I am going to assign the value of arr of j plus 1 is equals to temporary variable. So this is how swapping will take place in my bubble sort. So what I am doing, first of all, I am running my outer loop for turn is equals to 0 to n minus 1 times. So in this turn, in the number of turns, what I am doing, I am taking my largest element and pushing it towards the last of my element, towards the last of my array. After that, I am in the inner loop, I am checking whether my first element is greater than my second element. If yes, then swap those two values. If not, then don't need to do anything else. So this is the basic fundamental of bubble sort. So in the main program, first of all, let me create my array. Int arr is equals to 1 0 3 2 2 3 2 3 and 5. So this is my unsorted array. After that, I am calling my bubble sort function and passing arr as my argument. After that, let me run my loops to print my array after calling my function. So int I is equals to 0 and I should be less than arr dot length. Arr dot length. After that, I plus plus. Here, what I am doing, I am just simply printing my elements here. Arr of I, elements of my array, right? Plus a blank space. So this is the code for bubble sort. Now let me run this code. You can see that the array which is provided is 1 0 2 3 5. So this is an unsorted array. So after sorting, you can see that this is my sorted array. So this is how bubble sort works. So the outer loop will start from turn is equals to 0 to n minus 1, and in the inner loop the j value will start from 0 to n minus 2 minus turn, because I am not checking the last element, because I already suppose you can see that in the previous example 5 4 something elements, right? So 5 is the largest element in our previous example. So what I am doing, I am pushing the 5 value to the last of my index. After that, when turn value will become 1, then I don't need to check whether the 5 value is greater than my rest of array, because I already know that my 5 is the biggest element here. So I don't need to check for again and again. So to avoid that, we are running my inner loop from j is equals to 0 to n minus 2 minus 10. So this is how the code for bubble sort work. I hope you have understood the logic for bubble sort. Now let us study another type of sort. So when it comes to selection sort, the logic for selection sort is first of all we pick the smallest element in our array. So let us consider that 1 is the smallest, then we will pick 1 as my array. Here we will pick the smallest element from our unsorted array. After that, put it towards the beginning. So let us understand by taking an example. So this is the example and the size of the array is 5. So this is my array 5 4 1 3 2 and the indexes are 0 1 2 3 4. These are my indexes and this is the given array. Now the logic for selection sort is first of all we have to pick the smallest element present in our array. So how we can pick the smallest element? We already did in the arrays chapter. We found out the largest element and the least element in the given array. So we are using the same algorithm and the same logic and the same code for that, for selection sort also, to find the least element in the code. So what I am doing here, you can see that 5 4 1 3 2, the least element is 1. So I am taking 1 and placing it in the first index. After that I am taking my rest of my array as 5 4 3 2. So this is my unsorted part. After that in this unsorted part I am taking the least value. So here in this what is the least value? 2 is my least value. So I am taking 2 out. So 1 2 5 4 3. So this is my unsorted part. So in this, what is the least value? 3 is my least value. So I am picking or selecting 3 from my unsorted array. So I am pushing this after here, after the value of 2. So after my array will become 1 2 3 5 4. So this is my unsorted part right now. So in the unsorted part, how many elements? 2 elements are there. So again I am going to pick the least element. So in among 5 comma 4, which is the least element? 4 is the least element. So I am taking this and putting in front of 3. So 1 2 3 4 and 5. So 5 is the single element, so I don't need to sort it again. So finally here I am picking 4, I am selecting 4, and finally what I will get? I will get my sorted element. So 1 2 3 4 5. This is the sorted array in the increasing fashion. So this is how the working of selection sort work. So the pseudocode for this is, first of all I will run a loop from int I is equals to 0 to n minus 1. In this what I am doing, I am taking my minimum position. So I am assuming that my whatever the index I have is my minimum position. So I am taking minimum position is equals to ARR of I, and in the inner loop for int j is equals to I plus 1, and I am running this up to n times, up to the size of my array. So up to n minus 1 times, and in this I am checking whether my minimum position is greater than my any element present in my j. So if I am checking whether the minimum position that I have taken is greater than the any element present in my j. So ARR of minimum position is greater than ARR of j. If this condition is true, then j will become my minimum position. So minimum position will change into j. After that we will complete our inner loop. After that we will swap. In the outer loop, after completing the inner loop, in the outer loop we will swap the elements between minimum position and the given ith index. So I am going to store int temp is equals to ARR of minimum position. After that what I am doing ARR of minimum position. I am replacing the value of the element which is present in the minimum position as the element. After that ARR of I will become a temporary variable. So I am changing the values or the elements present at minimum position and the ith value. So you can see that here I have found out the minimum position in this array, and I am changing its value in the ith position. Here I is equals to 0. So I am taking my minimum position and placing at the 0th index. After that I will become 1. Here I will become 1, and I am taking the minimum position and putting here I is equals to 1. After that here the I is equals to 2. So the minimum position is 3, right? Minimum value is 3. So I am taking this and placing at I is equals to 2. After that here I will become 3. So I am taking 4, which is the minimum value in the unsorted part. I am placing it at I is equals to 3rd index. After that 5, placing it in the fourth index. So this is how the selection sort algorithm works. This is the pseudocode. And remember guys, for basic sorting techniques like bubble sort, we have already studied about bubble sort and selection sort and insertion sort, which we'll study in the next video. The time complexity for these three sorts are big of n square. Big of n square. This is the time complexity for these three basic sorting techniques, and this is not a technically speaking, this is not a good time complexity. Now let us create the code for selection sort. So first of all, let me create my public static void selection sort. Selection sort is the name of my function, and in that I am passing my array int arr. In this, first of all, let me calculate the size of my array. Int n is equal to arr dot length. After that I am running a loop for int I is equal to 0, and I should be less than less than or equals to n minus 1. I am running n minus 1 times. After that I plus plus. Here what I am taking the minimum position is equals to the ith element, ith index itself. After that, in the inner loop I am running int j is equals to I plus 1. After that, j should be less than n. After that, j plus plus. Here I am checking if my ARR of minimum position is greater than ARR of j. If this condition is true, then what I am doing, I am changing the minimum position. Minimum position is equals to j. Here you can observe one thing, that in the inner loop we are not swapping the two elements. So if we swap the any two elements in the inner loop, then it will become a bubble sort. In selection sort, we are not unnecessarily swapping any two numbers. We are just finding the minimum position in the whole array and taking it towards the first index, right? After that, here after changing, we complete up my inner loop. In the outer loop, swapping will take place. So what I am changing the minimum position index element to my ith element. So what I am doing, I am creating a temporary variable. Temp is equals to ARR of minimum position. After that, ARR of minimum position is equals to ARR of I, and ARR of I is equals to ARR a temporary variable. So this is how the code for selection sort works. Now in the main program, instead of calling bubble sort, let me call here selection sort. In this, pass my ARR. You can see that my element, the array is 1 0 2 3 5, and after sorting my array will become 0 1 2 3 5. So here instead of calling bubble sort, I am calling selection sort, and after calling selection sort, I am running my for loop. So we already know that array get passed by reference, and whatever the changes happens in the function, that will reflect in my main program. So whatever the changes that will happen to this unsorted array, that will get reflect in my for loop. Now let me run this code. So if the code works, then I will get a sorted array. You can see that my codes work such that I will get a sorted array. So my actual array is 1 0 2 3 5, and after applying selection sort, you can see that my array become 0 1 2 3 5. This is a sorted array in the increasing fashion. So this is the code for selection sort. Now let us talk about the third kind of sorting technique, that is insertion sort. Now these insertion sort inspiration comes from cards. So if you have some siblings, then you might have played cards with them. So let us consider that these are my cards. Let us consider 4 1 2 and 3 and 5, something like whatever. So we used to pick the highest number of the card, right? Suppose if you have 10 cards, then we used to pick, when we are playing cards with our sibling, then we used to pick the card which has the highest number, because that will get the chances of winning. Similarly here, we will pick a card, we will pick an element. Here we will pick one and we will place it in front of all. After that, this is the unsorted part. So here we will pick one. After this will remain my unsorted part, and here we will pick again the least value, and after that 4, after that 5. So this is how picking elements from the given array is known as insertion sort. So this is known as insertion sort. So the idea here is pick an element from the unsorted part and place it in the right position. So let us consider that this is my these are my cards or elements, whatever you can say, 3, 2 and sub 0. So here I am going to pick, you can see that my 0 should be at first position. So what I am doing, I am changing the position of 0 by just picking it. So I will pick 0 and place it at the 0th position, and I will replace the 3 value at the third index. Whereas in my selection sort, what I am doing, I am taking the least value and putting it towards my first index. But here I am picking the least element or whatever element I want, and I am placing it to that respective position according to my sorting, right? Here I want to place 0 to my first index or the first location. So what I am doing, I am just placing 0, replacing the value of 2 and 3, 0 and 3. So 2 will remain here after 3. So this is how picking and placing it in the right position takes place. Now let us talk about the pseudocode of this code. Now let us understand how the insertion sort works by taking an example. So this is the example, right? 0. These are my elements and the indexes are 0, 1, 2, 3, 4, right? So I will consider that the first element, I will pick that the first element is my sorted part and the rest of my array is unsorted part, right? I will assume that I will pick that the first element is the sorted part. I am picking that my first element, whatever the first element, is sorted and the rest of the array is unsorted. And after it, I am comparing the rest of, this is my rest of the array, right? I am comparing 4 with 5. So if 4 is greater than 5, then 4 will come here, after it 5 will come here, and this is my sorted part, and the remaining array 1, 3, 2. This is my unsorted part. After it, I am comparing this element with 4 comma 5, and if this is greater than, then it will come, if 4 comma 5 is less than 1, or if 4 comma 5 is greater than 1, then 1 will come at the first. So 1 comma 4 comma 5, this is my sorted part now, and 3 comma 2 is the unsorted part. Again, I am comparing 3 with the rest of my sorted part. So what I will get, I will insert these 3 element in between the sorted part by comparing, right? So 1 comma 3 comma 4 comma 5, these are my sorted parts, and 2 is my unsorted part. Again, I am comparing this unsorted part with my sorted part. Again, I will compare with all the elements, and finally at the fixed position or at the perfect position, by comparing, I will pick my element 2 and position it at that particular position, right? 1 comma 2 comma 3 comma 4 comma 5. So this is my sorted array. From this to this, we got from the previous array, this array is an unsorted array, and the final array we got is a sorted array. So you can understand that I have picked the first element as sorted one, and I have compared with the rest of my unsorted array, and by comparing the rest of the unsorted array, I have finally created array or altered my array which is sorted. So this is how insertion sort works. Now here let me create first of all my insertion sort. In the insertion sort, first of all, let me create my function public static void main void insertion sort. In the insertion sort, I am passing my array int arr. After that, first of all, let me calculate the size of my array. Arr is equal to arr dot length is n. After that, I am running my for loop for int I is equal to 0 and I should be less than n. After that I plus plus. In this, what I am doing, I am first of all creating my current variable. Current is equal to I. After that, my previous variable int pre is equal to previous is equal to I minus 1. That is the element beside the current variable. That is the element which is at the left side of my current variable. After that, in the while loop, I am checking my previous should be greater than or equal to 0, and my if my previous element is greater than my current element. If this condition is true, then I will come inside the loop, and what I am doing arr of previous plus 1 is equals to arr of previous, right? Arr of previous here, previous error of previous. After that, previous minus minus, I am decrementing the previous value by 1, and in the outer loop, after completing while loop, I am changing error of previous plus 1 is equals to error of current. I am changing its value by current value here. Now in the main program, let me call, in the place of selection sort, let me call my insertion sort. Insertion sort. In that I am passing the value of n ARR. After that I am printing whatever the values of particular array. Now save this thing and run. Wait a minute, I have to give here first of all current, here current element. After it, here previous minus minus, not pre minus minus. In the current position we are storing that index. So in the place of index, what we are doing, let us store the element itself, error of I, and change here as current. In the place of error, we are storing the element itself, right? So write current here in the place of error of current, because we are storing in the current variable, we are storing the element itself. Now I am writing current and save this thing, and now finally run. You can see that we got our sorted array. So this is the provided array here, and this is the this is unsorted array. In the line 46, the array which is provided is unsorted, and after sorting you can see that this is the sorted array. So this is the code for insertion sort. This is the code for insertion sort. I hope you are making notes and the logics by yourself, and making notes, your own notes, especially your notes is very important when it comes to data structures and algorithms. Up to now we have studied about bubble sort, insertion sort, and selection sort. Now let us talk about inbuilt sort. So in Java collection frameworks, when we are importing java.util.array, this is a package in Java. When we import this these java.util.arrays or java.util dot star is for everything, math.max or max.minimum value, max.pow, or math.comparison, and all those things. So star means everything. We are importing whatever the packages we have, just import to our program. So you can write in the place of java.util.star, in the place you can write also this. Now we can sort our array using our inbuilt functions also. Suppose let us take this is our array 0, -1, 2, 5. Here this is unsorted array, right? So after sorting, what I will get? -1, 0, 2, 5. So this is the sorted array in the increasing fashion. So we can directly apply when we are doing actual programming, competitive programming in lead code, HackerRank, and like coding platforms, or when we are in an interview and we will have some limited time, right? So to we will avoid all the sorting and all those things, and we'll just use inbuilt sort on those scenarios. But understanding the logic for sorting, like bubble sort, selection sort, understanding the logic of these sort of sorting techniques will increase our thinking ability. And when it comes to competitive coding, we use inbuilt sort because it has good time complexity and it is easy to implement, first of all. So to sort an array, we will use a function which is we will write first of all capital A arrays, ARR arrays dot sort, and we will write, suppose the given array name is ARR. So in this we will pass ARR. So by doing or by writing this one line, our code or our elements in the array will get sorted in ascending order. So this is how we will use inbuilt sort, and this might sound like a we are studying bubble sort, insertion sort very hardly. We are what is this inbuilt sort and all those things, but this is useful when it comes to competitive coding and interviews. If the interviewer asks you that you have to build your own sorting technique, then and only you should go to bubble sort and all those sorting techniques. If the interviewer didn't ask you about implement the sort and all those things, then you have to use inbuilt sort always. Remember guys that inbuilt sort, the time complexity is n log n, right? The time complexity of inbuilt sort is n log n, whereas bubble sort, selection sort, and insertion sort, the time complexity of these three sorts are, we are using 2 loops in each sort, so the time complexity is around big of n square. So this is more efficient then these are combining all sorts. So when it comes to competitive coding or interviews, we we always tries to use inbuilt sort because it is easy. You can see that it is just minimum barely one line. So we will always use inbuilt sort. This might sound cheating to you, but it is good. It is good and it is useful in some scenarios, right? So suppose let us take an element to understand this line. Let us take an element that I have elements like 0, -1, -2, 5, 3. Now I want to sort only the first three elements. So I don't want to sort these two elements because I just want to sort these first three elements. So to do that, what I will write these are the indexes, right? 0, 1, 2, 3, 4. Right, I will write arrays, capital A, arrays dot sort, and I will write, let us consider my array name is ARR. After that, my starting index, that is 0, and my ending index, that is 2. Right, this will give me as output as, this line will give me output as -2, -1, 0, 5, 3. So if I put arrays dot sort and just without giving the indexes, I will just wrote the name, then it will sort the all elements of my array. So my array will become, if I give this line, then array will become -2, -1, 0, 3, 3, sorry, 3, 5. Yeah, so my array will become this, and if I give indexes, starting index and minus ending index, then it will only sort up to the starting and the ending index. So this is the concept of inbuilt sort. Now let us talk about counting sort. So to understand counting sort, first of all we have to remember that the counting sort is only applicable for a limited range of numbers. Suppose if we are taking the marks of students, then we know that marks lies from 0 to 99. Suppose if I am taking a bike, then I know that the at max the bike will be from 0 to 1 lakh. So this is the range of my bike, two wheelers, and this is the range of my marks. Marks is the accurate example, and bikes maybe 24 lakhs or whatever it is. So bikes is not accurate example, I guess, but marks is. So we already know that my marks lies in the range of 0 to 99 or 0 to 100. So we know what will be the range of my numbers. So at max my user will get 100, and minimum value will get 0. So I know that the numbers, whatever the array is, what how much the size of my array, irrespective of my size of array, I know that the elements will lie in this range. If I know the range of my elements, then I can apply my counting sort. And in some scenarios I want to tell you that my counting sort will go sometimes linear. It will give us linear time complexity. So it is a very good time complexity. You know that we already studied inbuilt sort, and for inbuilt sort the time complexity is log n, and here the time complexity is n, big of n. So this is more way efficient, but the only catch here is we need to know the range of my numbers. So here these are my elements: 1, 4, 1, 3, 2, 4, 3, 7. These are my elements, right? So I can see that my elements are from 0 to at max 8. So I will create my array of size 8, and here I will store, these are my numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8. These are my numbers, right? These are my numbers. So I will name the array as count array. So this array will keep a count on number of occurrence that will happen in my given array. So this is my given array, right? So I will initialize all the elements. I will initialize all the 0, 1, 2, 3, all the numbers with 0. Right? 0 initially, 0, 0, 0, 0, 0, 0, 0, 0. Right? Okay. Now I will iterate at each element. And I will increase the count value. So this count variable will keep a frequency, how many times a particular element is occurring in my given array. So here first element is 1. So in the place of 1 I will strike out, and the number of occurrences 1 now. After that 4. So after at fourth location I will go at the fourth location and I will write 1 here. After that 1, again 1. So what is the value of 1? Here the value of 1 is 1. number of occurrences once, and I am going to change it 2. So 1 occurred 2 times. After that 3. So at the place of 3 I will write 1. After that 2. So at the place of 2 I will go and strike out and write 1. After that 4. So what is the occurrence of 4? 1. So it will change into 2. After that 3. 3 how many times occurred? 1 time. So 2. After that finally 7. So in the place of 7 I will write 1. At the place of 0 I will write 1. So count variable will keep a frequency of how many times a particular element is occurring in my given array. After that I will create another array in the original array. I am not gonna create another array in the original array. Listen to me properly, that in the original array what I am doing, I am sorting in the order of number of occurrence. So you can see that the number of occurrences of 1 is 2. So I am going to change the elements as first of all I will write 1. After that I will strike out to 1. After that I will reduce 1 in the number of occurrence. I will reduce the value of 2 from 2 to 1. After that I will write again 1. It will now the number of occurrence will become 0. After that third element, I hope you have understood that. After that second element, so number of second 2 is 1. So I will write 2 here. After that 1, the number of occurrence will become 0. For 3 number of occurrence is 2. So at the place of 2 I will strike out and write 1, and I will print here 3. After that here at the place of 1 I will write 0, and again 3. After that I at the place of 4, what is the occurrence of 4? 2. So at the place of 2 I will write 1. After that here I will print 4. After that at the place of 4 occurrence I will print 0 here, and finally print 4. After that you can see that at 5 number of occurrence is 0, so no need to print anything. At the occurrence of 6 number of occurrence is 0. At 7 number of occurrence is 1, so I will print 1 time, and my 1 will become 0. After that at the 8th position, at the 8th element, number of occurrence is 0, so no need to print my array. So you can see that in the original array, after taking the number of occurrence and reducing the value of frequency, I got my sorted array. So this is the concept of counting sort. I hope you have understood, and if you didn't, then rewind the video again and surely you will understand. So let us write the pseudocode for counting sort. So first of all, my pseudocode, what I'm gonna do, first of all I need to create a count array, right? To create count array, first of all let me create a variable int largest is equals to integer dot minimum value. After that let me run my loop. I'm running my loop and taking the number of occurrence at each value, at the given element range. So I will start int I is equals to 1 and I should be less than n. After that I plus plus. Here what I am doing, I am taking the largest value first of all. So first of all I need to know that the range, right? Suppose the maximum element is 99. Then by finding the maximum element, we already know that counting sort will only work on the range of elements. So if the maximum element is 99, then I can say that my elements will go from 0 to 99. And also one thing, that counting sort is mostly used for positive numbers only. So counting sort is most of the times is used for positive numbers and for a given range of numbers. So these are the two limitations for counting sort, but it is a good sorting technique because it sometimes gives a linear time complexity. So it is considered as a good coding or a good sorting technique. Now to find out largest, what I am gonna do, I am comparing math dot maximum value of largest comma my ARR of I. So this is how I'm gonna find out the largest. By running a loop I will find out the largest of the given element or the given array. After that I will create my count variable that will keep track of my array, that will keep track of occurrence of each element in my array. So I am going to create, right? After that I am assigning its size as a largest plus 1. Suppose my largest is 99, then my size of my array is 100 because I am starting with 0, right? 0 to 99. So 1, right? After that I am running a loop and checking each occurrence of my each element. So I is equals to 0 and I should be less than n. After that I plus plus. Here what I am doing, I am doing count count of ARR of I. At each element, if the element is occurred, then I am going to increase my uh, count value. So in the place at that particular index, I'm going to change or increase the value of count. So you can see that at 1, the 1 occurred 2 times. So initially the occurrence is 0. So from 0, my frequency will become 1. After that, 1 will become 2. So the number of occurrence of 2 here is 2 times. So my frequency is 2. So this is how I am going to calculate my frequency. So I have successfully find out the largest element and count variable. After that, I am going to sort my elements. So after that, sorting step will come here. To sort, I am going to create a variable int j is equals to 0. After that, I am going to run my loop. Int I is equals to 0 to I should be less than count dot length. After that, in the for loop, I am running a while loop while count of I is greater than 0. While count of I, suppose I'm here, you can see that the count of 1 is 2. It has occurred 2 times. So the count of that particular index is 2, right? So what I am doing, I am printing or I am assigning the value of j is equals to I. Value of j is equals to I. After that, what I am doing, I am doing j plus plus and count of I minus minus. I am frequency is decreasing, right, from 2 to 1, 1 to 0. You can see that the frequency is decreasing. So these are the things I am doing, and this is the pseudocode. This is the pseudocode for my counting sort. So if you didn't understand, let me tell you again. So first of all, counting sort is only applicable for the range of given numbers and most of the times positive numbers, right? And the time complexity of counting sort or count sort is much more efficient than rest of the algorithms which is present in our sorting algorithms, right? So it is efficient, and the counting sort, the only limitation is it is only applicable on the range of numbers. So to apply count sort, we need to know what's the range, what's the maximum range of the numbers that we are having in my array. So to find out range, I used the largest element. I find out the largest element, and using the largest element, I have created a count array. So count array will keep track of how many times a particular element has occurred. After creating count array, I run the loop. You can see that I have run the loop, and by running a loop, I have calculated the number of occurrence of a particular element. After that, the third step is sorting algorithm. So I have initialized j is equals to 0. This is my initialization step. After that, I have started my for loop from I is equals to 0 to count length in the inner loop. I have written while. After that, in the count of I is greater than 0, in that I am assigning ARR of j is equals to I. After that, I am incrementing the value of j and decrementing the value of count. So these are the steps that are involved. Now let us code this thing. By coding, you will understand it even more better. Now here, let me create my count sort. COUNT count. Yes, what is sort? So public static void COUNT count. Yes, what is sort? In this, pass int ARR. After that, here, first of all, let me create my largest. Int largest is equals to integer dot minimum value. After that, I am running my for loop for. Before that, let me calculate the size of my array. So int n is equals to ARR dot length. After that, I am running my for loop for int I is equals to 0 and I should be less than n. After that, I plus plus. Here I am running my taking my largest element is equals to math dot max of largest comma ARR of I. Right? After that, what I am doing, I am creating a count array. Count is equals to new int, and the size of the array is largest plus 1. Because I am including 0. right? After that, I'm running a loop to find out the number of occurrence of each character of the each element. I should be less than n. After that, I plus plus. Here, what I'm doing, incrementing the count. So ARR of I, after that plus plus. Now the sorting step. The sorting step. In the sorting step, I am going to initialize int j is equals to 0. After that, my for loop for int I is equals to int I is equals to 0. After that, I should be less than count dot length. After that, I plus plus. In the in the inner loop, I am writing while my ARR my count of I is greater than 0. My count of I is greater than 0. What I am doing, ARR of j is equals to I. After that, count of I minus minus. After that, j plus plus. This is how the count sort will take place. Now let me save here and let me comment it out and call my counting sort. Count sort. Save this thing and run. Here I have to give math. Save this. Let me delete and again run. You can see that we got our sorted array. So this is the provided array and unsorted provided array, and after sorting, this is the result I got. So I hope you have understood the concept of sorting array, and I need to write the algorithm or write the code for count sort, selection sort, and bubble sort, and finally insertion sort. So these are the 4 sorting techniques, and we have understood them in detail. Now we are going to start our next chapter, that is 2D arrays. So with that being said, I hope you have understood all the concepts, and if you didn't, then rewind the video again. Definitely you will understand. If you didn't, then go into Google and search and try it yourself. First of all, you need to do your problems on your paper. Understand the question first. After that, we can do whatever things we want. So with that being said, I will see you in the next chapter, that is 2-dimensional arrays.